What if the sun is triggering earthquakes, and we have been ignoring the evidence for decades? That sounds insane. But a growing body of peer-reviewed research is forcing scientists to take this idea seriously, and the implications are terrifying. Let me explain. In May 2024, the most powerful solar storm in over 20 years slammed into Earth. It was classified G5, the highest level on the geomagnetic storm scale. The Gannon storm, as it was named, was the strongest since November 2003. Auroras were visible as far south as Mexico and India. Power grids were stressed. GPS systems glitched globally. But something else happened that most news outlets completely ignored. In the weeks surrounding that storm, significant seismic activity was reported across multiple tectonic regions. Coincidence? Maybe. But here is where it gets uncomfortable for mainstream geology. In 2020, a team of researchers led by Vito Marcatelli published a study in Scientific Reports, which is part of the Nature portfolio. They analyzed over 20 years of seismic data alongside solar activity records. Their finding was striking. There was a statistically significant correlation between high solar proton density hitting Earth and an increase in large earthquakes, magnitude 5.6 and above. This was not a fringe blog. This was peer-reviewed research in one of the most respected scientific publications on the planet. Now stop. Before you dismiss this, understand the proposed mechanism because it is grounded in real physics. When a massive coronal mass ejection hits Earth, it compresses and distorts the magnetosphere. This disturbance induces what scientists call telluric currents, electrical currents that flow through the Earth's crust and upper mantle. These currents are measurable. They are documented. Geophysicists have studied them for over a century in the context of telegraph disruptions and pipeline corrosion. The controversial leap is this. Some researchers propose that these induced electrical currents could interact with fault zones already under extreme tectonic stress. Quartz-bearing rocks, which are abundant in fault regions, exhibit the piezoelectric effect. They generate electrical charge under mechanical stress and conversely can deform under electrical influence. The theory suggests that externally induced currents might provide just enough additional stress to push a critically loaded fault past its breaking point. Now here is why the scientific establishment pushes back hard. The United States Geological Survey maintains that no reliable method exists to predict earthquakes and that no proven causal connection between solar activity and seismic events has been established. Correlation in datasets does not prove causation. Earth experiences roughly 55 earthquakes per day. Solar activity fluctuates constantly. Finding overlapping patterns could be statistical noise. But here's the part that keeps researchers digging. We are currently in solar cycle 25, which has been significantly more active than originally predicted. NASA and NOAA initially forecast a weak cycle. Instead, sunspot counts have repeatedly exceeded predictions. Some solar physicists expect elevated activity extending into 2026 and beyond. If the solar seismic hypothesis holds any validity, we are living through exactly the kind of period where it would matter most. No one is claiming the sun directly causes earthquakes. Tectonic stress built over centuries is the primary driver. The question is whether solar storms can act as a trigger for faults already on the verge of rupture. That distinction is critical and still unresolved. This is one of the most fascinating open questions in geophysics right now. If you want to stay ahead of the science that mainstream media is not covering, follow this page. Now I want to hear from you. Do you think the sun plays a role in triggering earthquakes? Or is this just pattern seeking and random data? Fight it out in the comments.